In this session, we'll start with geometric progression. Geometric progression is a sequence of non-zero numbers if the ratio of the term and the term preceding to it is always constant. It means if we have a progression a1, a2, a3 and so on up to an, then the ratio of a2 by a1 equals ratio of a3 by a2 equals ratio of a4 by a3 and so on up to an by an minus 1, and this ratio we denote by r, which is known as the common ratio. For example, if I take a progression like 1, 2, 4, 4, 8, 16, etc., then it becomes a GP. Because the ratio of 2 and 1 is 2:1, ratio of 4 and 2 is 4:2, that is 2:1, and so on. Now, whenever we have a progression that is in GP or it's a geometric progression, we have a formula to find the nth term. The nth term we generally represent by Tn. So Tn is equal to A times r raised to the power n minus 1. And similarly, if we have the last term denoted by L, if n is the last term, if n is the last position and L is the last term, then the nth term from the last term, that is if we have say 10 terms, the 10th is the last term and we want to count backwards, that is second term from the last term. The second term from the last term will be the 9th term, or say the third term from the last term. So for that, the formula is Tn dash is equal to L divided by r raised to the power n minus 1. For example, if we want to find the fourth term from the last term, and if L is the last term, then it will be L divided by r raised to the power 4 minus 1. Now the next is the summation of n terms of a GP. If we have a GP with the first term as A and the common ratio as R, then the sum of n terms of the GP is given by Sn is equal to A into r raised to power n minus 1 divided by r minus 1. This formula we use when r is greater than 1. Similarly, if r is less than 1, then the formula for the summation is A into 1 minus r raised to power n over 1 minus r. And when r is equal to 0, it means there will not be a GP or a progression. We cannot have a progression or a GP or a geometric progression where the common ratio is 0. And these formula we generally use when we have a finite progression, that is the number of terms is countable. If the number of terms is uncountable, or we want to find the sum of infinite series, or then the formula is Sn is equal to A over 1 minus r, and in this case the absolute value of r is less than 1. Now some important points regarding the GP. The first is, if A is greater than 0, then GP is increasing if r is greater than 1 and decreasing if the value of r is lying between 0 and 1. Similarly, if A is less than 0, then GP is increasing if R lies between 0 and 1 and is decreasing R is greater than 1. If A, B, C, D, etc. are in GP, then they are also in continued proportion. It means the ratio of A is to B will be equal to the ratio of B is to C will be equal to the ratio of C is to D. So whenever we have three numbers A, B, C such that A is to B is equal to B is to C, then it is said to be in continued proportion. If the first term of the GP with n terms is a, that is the first term is a and the total number of the terms is n, and the last term is L, then the product of all terms of the GP is AL whole raised to the power n by 2. Product means if we take the terms as A, the second term AR, then AR square, then AR cube, and so on. So it means the product is A multiplied with AR multiplied with AR square multiplied with AR cube. This all will be equal to AL raised to the power n by 2, where A is the first term, L is the last term, and n is the total number of terms. If A, B, C are in AP as well as it is in GP, then it means A is equal to B is equal to C. Now the one important application of GP is to find the value of a recurring decimal. If we have a number of the form A point B, 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 etc. For example, if we have a number 1.3333, a recurring decimal where A is equal to 1 and B is equal to 3, then the general form of the recurring decimal, we can write it as 0.xy, where x is occurring n times, y is occurring n times, then the resultant will be equal to, or we can say that the recurring decimal can be represented in fractional form or p by q form as xy minus x divided by 10 raised to the power m plus n minus 10 raised to the power n, where x is occurring m times and y is occurring n times. Now let's take one problem over here. The number of bacteria in a certain culture doubles every hour. It means, say at the beginning, if it is 1, then the next hour it will be 2, the next hour it will be the double of 2, that is 4, then double of 4, that is 8, and so on. If there were 30 bacteria present in the culture originally, that is at t is equal to 0, then the number of bacteria that will be present at the end of second hour, fourth hour, and nth hour. So we have to select the correct option. Here the correct option is C. Now let's see how to obtain the answer. Here the number of bacteria present in the culture will be in GP, where the first term A is equal to 30 and the common ratio is equal to 2. Now we know that the nth term is given by A raised to the power n minus 1. So after the second hour, it means the beginning of the third hour. So therefore t is equal to 3. So therefore the formula will become A raised to the power 3 minus 1, which is equal to AR square. So 30 multiplied by 2 square is equal to 120. Similarly, we can find for the fourth hour and the nth hour. Now the next one is to find the sum of the series, the summation of the series 5 plus 55 plus 555 plus so on up to n terms, and the options given over here. Here the correct option is B, that is 5 by 81 into 10 raised power n plus 1 minus 9n minus 10. Now the series given over here is 5 plus 55 plus 555 plus so on up to n times. Now this we can write it as, by taking 5 common, we get 1 plus 1 1 plus 1 1 and so on. Again we'll take 1 by 9 commons, 5 by 9 is common, so it will be 999 plus 999 plus so on. Now 9 we can write it as 10 minus 1, 99 is 100 minus 1, 999 is 1000 minus 1, and so on. Now we can segregate the two series. One is 10, 100, 1000 and so on. The other one is minus 1, minus 1, minus 1. So segregating we get 10 plus 100 plus 1000 plus 10,000 plus so on, and minus 1 plus 1 plus and so on. Now this series 10, 100, 1000 is a geometric progression, so we can use the geometric progression formula to find the summation. So it will be 10 into 10 raised power n minus 1 divided by 10 minus 1, and minus 1 plus 1 plus 1 so on up to n times it will be n, and simplifying it we get 5 by 81 into 10 raised power n minus 1 minus 10 minus 9n. Now the next is, if A, B, C are the pth, qth and rth terms of the GP respectively, that is pth term is A, qth term is B, rth term is C, then we want to find the value of q minus r log A plus r minus p log B plus p minus q log C. And here the correct option is 0. That is the this expression is equal to 0. Now let's start with the first term as A and the common ratio as R. Then we have A is equal to A R raised to the power P minus 1, because A is the pth term. Similarly, we have B is equal to A raised power Q minus 1. Now if A is equal to A raised power R minus 1, if we take log on both sides, we get log A is equal to log A, capital A, plus P minus 1 log R. Similarly, for B we'll get this expression, C also will get this expression. Now we want to find the summation of all these, so we'll add log A plus log B plus log C, and then multiply it with Q minus R. So Q minus R log A plus R minus P log B plus P minus Q log C will be equal to Q minus R in place of log A. Log small a, we substitute this value, log small b will substitute this value, and after substituting this value we'll get this expression. Now from here log a and log a will take common, so we are left with q minus r, and from here r minus p, and from here p minus q. Similarly, log r also we can take common, so we'll be left with p minus q minus r into p minus 1 plus r minus p into p q minus 1, and so on. Now if we open the brackets, this will become 0, because q and minus q it's 0, and here also minus r and plus r is 0, and similarly here qp will get, and similarly from here also we get minus pq. So if we solve it, here also it is 0, so it is log a into 0 plus log r into 0, which will be equal to 0. Now some important results related to GP. If each term of the GP is multiplied or divided by a non-zero constant C, then the resultant sequence will also be in GP with the common ratio equals to R divided or multiplied by the constant. Similarly, if we have two GPs, the first is AR square, and the second one is A1 R1, and so on, then the sequences obtained by multiplying A with A1, then AR with A1 R1, and so on, or by dividing, will always be in GP, where in the first case RR1 will be the common ratio, in the second case R divided by R1 will be the common ratio. The reciprocal of GP also will be a GP. If we have any progression which is in GP, if we take the reciprocal of the terms, then also it will be in GP. If A1, A2, A3 and so on is in GP, then the log of this will be in AP, and the converse is not true. The next one is the odd number of terms of the GP. So whenever we have a problem where we have a situation where we want to take some numbers or the odd numbers of odd number of terms. For example, the problem is there are 3 numbers which are in GP, or say 5 numbers which are in GP. So whenever we have a problem where it involves the odd number of terms in GP, we always take like AR cube, AR square, A by R, and so on. For example, if we want to take 3 numbers, then it will be AR, A by R. If we want to take 5 numbers, it will be AR square, AR, A by R, A by R square. But if we want to take the even number of terms in a GP, we always take as AR5, AR cube, AR, A by R, A by R cube, A by R5, and so on. Now if A1, A2, A3 and so on up to AN are in GP, then A1 raised to the power K, A2 raised to the power K and so on will also be in GP with the common ratio equal to R raised to the power K. If the next one is if A1, A2, A3 and so on up to AN are in AP, then A raised to the power A1, A raised to the power A2, that is these terms will be in GP whose common ratio will be A raised to the power D, where D is the common difference of the AP, that is A2 minus A1. If A1, A2, A3 and B1, B2, B3 are two GPs, then the sum and the differences of the two GP will not be a GP. In a GP, the product of two terms equidistant from the beginning and the end is a constant and is equal to the product of the first and the last term. So it means if we have a GP A1, A2 and so on up to AN, then A1 into AN, that is first and the last, is equal to the product of the remaining terms. Now let's take one problem here. The three numbers form an increasing GP, that is the value of R is greater than 1. Now if the middle number is doubled, then the new numbers will be in GP. Now we want to find the common ratio of the GP. Now since we want to take the three numbers in a GP, so we'll take the three numbers as A by R, A and AR. And it's an increasing GP, so R is greater than 1. Now according to the question, if we double the second term, that is A becomes 2A, then the sequence or the progression will be A by R, 2A and AR, and it is in AP. Now whenever we have A, B, C in AP, then twice of B is always equal to A plus C. So therefore twice of 2A, that is 4A, will be equal to the sum of the first and the third term, that is A by R plus AR. So solving it, we get this equation, and simplifying this, we get this equation, and solving this equation, we get two values of R. That is R is equal to 2 plus the square root of 3 and R is equal to 2 minus the square root of 3. Now since according to the question R is greater than 1, we cannot have a value 2 minus square root of 3. So therefore the correct option is R is equal to 2 plus square root of 3. Now the next is if ax cube plus bx square plus cx plus d is divisible by ax square plus c, then a, b, c, d are in AP, GP, HP or none of these. Now since ax cube plus bx square plus cx plus d is divisible by ax cube plus c, it means if we divide this expression by this expression, then we should get remainder 0. Now if we divide this expression by ax square plus c, we get the remainder which is equal to d minus bc by a. So therefore it has to be equal to 0. So d minus bc by a is equal to 0. Solving it, we get bc is equal to ad, and finally arranging the terms, we get b by a is equal to d by c, which means a, b, c, d are in GP. Now is the insertion of geometric means between two numbers. Now if we have two numbers A and B and we insert a number of terms, say n geometric means like G1, G2, G3 so on up to Gn, then the numbers A, G1, G2, G3 and so on up to Gn, so on up to B will be in GP. Then only we say that G1, G2, G3 and so on up to Gn are the geometric means or n geometric means of the two numbers a and b. Now here we already have two numbers a and b, then we inserted n numbers, the n geometric mean, so therefore the total number of terms in this GP will be n plus 2. And if we have the common ratio equal to r, then b will be equal to a raised to the power n plus 2 minus 1 using the nth term formula, and solving it we get r is equal to b by a raised to the power 1 over n plus 1. So this is the formula for finding the common ratio whenever we have two numbers a and b, and if we insert n geometric means. So we can use that formula to find the geometric means. G1 will be equal to AR because G1 is the second term. G1 is the second term of the GP, G2 is the third term of the GP, so we can find the values of G1, G2 and so on. Now if we put K is equal to 1 and N is equal to 1, then we get G1 is equal to A into B by A raised to the power 1 over 1 minus 1 plus 1. So this will be equal to A over B by A raised to the power 1 by 2, and solving it we get AB raised to the power 1 by 2, which is equal to square root of AB. This is square root of AB is called the geometric means between the two numbers A and B. So this is known as the geometric mean. Geometric mean of two numbers A and B is equal to square root of AB. Now some important facts related to the geometric mean. The product of n geometric means between A and B is equal to nth power of the geometric mean of two numbers A and B. That is, if we have two numbers A and B, and if we insert n geometric means G1, G2, G3 and so on up to Gn, then G1 into G2 into G3 so on up to Gn will be equal to AB raised to the power n by 2, which is equal to G raised to the power n. The product of n geometric means between A and 1 by A is always equal to 1. And the geometric means of n positive numbers is always equal to A1 into A2 into A3 into A4 into so on up to An whole raised to the power 1 by n. For example, if I want to find the geometric mean of 1, 2, 4 and 8, then it will be 1 into 2 into 4 into 8 whole raised to the power 1 by 4. If A and G are the arithmetic mean and geometric mean between two positive numbers, then the numbers are A plus minus square root of A square minus G square. And similarly, if A and G are arithmetic means and geometric means respectively between two positive numbers A and B, then the quadratic equations having A and B as its roots is x square minus 2ax plus g square is equal to 0. Now let's take one problem. If we insert two numbers between 3 and 81 so that the resulting numbers are in GP, that is, we want to insert two geometric means between 3 and 81, then the two numbers will be 927, 827, 925 or so on. Here the correct answer is A. So let's take the two numbers be A and B, and originally we have the numbers 3 and 81, so therefore 3, A, B and 81 are in GP. Now the nth term Tn is equal to A into R raised by n minus 1. So here we have the total number of terms n is equal to 4, the first term A is equal to 3, and the last term Tn is equal to 81. Substituting the respective values, we get 81 is equal to A, that is 3 into R raised by 4 minus 1, and solving it we get R is equal to 3. Now substituting this value R is equal to 3 back in this, 81 is equal to 3 into R raised by 3, we get 81 is equal to A into 3 raised to the power 3, so A is equal to 3. Now we want to find the value of A. A is the second term, so it will be equal to AR. B is the third term, AR square. And substituting the values over here, AR is equal to 9, AR square is equal to 27. So therefore the two numbers are 9 and 27. Now the next is the harmonic progression. A sequence is said to be in harmonic progression if the reciprocal of the terms of the sequence is in AP. That is, the terms A1, A2, A3 and so on up to AN will be in HP or harmonic progression when 1 by A1, 1 by A2, 1 by A3 and so on up to 1 by AN are in AP or arithmetic progression. That is, they will be having a common difference. Now to find the nth term of the AP from the HP from the beginning, we use the formula Tn is equal to 1 over A1 plus n minus 1 into 1 over A2 minus 1 over A1. Now here A1 is the first term of the HP, so therefore 1 over A1 it will be the first term of the AP, and in AP we have the formula the first term plus n minus 1 into common difference. So common difference we can find by taking the difference of the two consecutive terms, and solving it we get nth term is equal to A1 into A2 divided by A2 into n minus 1 into A1 minus A2. Similarly, we can find the nth term of the HP from the end. So in place of 1 over A1 we'll be having 1 over AN, and solving it we get A1 A2 AN divided by A1 A2 minus AN multiplied with n minus 1 into A1 minus A2. So this formula we can use if we know the first term, the second term or the terms in the HP to find the nth term from the end. Now some important terms points related to HP. No term of HP can be 0, because if a term in an HP is 0 then the reciprocal will be undefined, and we cannot have an undefined term in arithmetic progression. The second one is the nth term of the HP is the reciprocal of the nth term of the corresponding AP, and there is no fixed formula for finding the sum of the HP sequence. Now let's take one problem. The 20th term of the HP is 1, the 30th term is minus 1 by 17. Now we want to find the largest term or the last term. Now here the answer is 1. The 20th term of the HP is given as 1. So 20th term of the AP will be A plus 19D. So reciprocal of it will be 1 over A plus 19D is equal to 1. Similarly, the 30th term will be 1 over A plus 29D is equal to minus 1 by 17. So we get the two equations. A plus 19D is 1 and A plus 29D is equal to minus 17. Solving the two, we get the values of A and B, A and D, and now we can find the largest term or the nth term as 1 over A, the value 176 by 5 plus n minus 1 into D, and solving it we get 5 over 185 minus 9n. Now this value will be largest when 185 minus 9n will be the smallest or least, and it will have the smallest value when n is equal to 20. So therefore the largest term will be the 20th term or the last term, and we can substitute the value of n is equal to 20 here, and solving it we get 1. So therefore the largest term is 1. Now the next is the harmonic mean, insertion of harmonic mean between two numbers. If h1, h2, h3 and so on up to hn be n harmonic means between the two numbers a and b, then a, h1, h2, h3 and so on up to b will be in HP. And we can also say that 1 over A, 1 over H1, 1 over H2 and so on up to 1 over B will be in AP, and there will be total number of terms will be n plus 2, because two numbers are already there, A and B, and n harmonic means are inserted between them. Now here, if D is the common difference of the corresponding AP, then 1 over B will be equal to 1 over A plus n plus 2 minus 1 into D, using the formula for the AP. And solving it, we get D is equal to A minus B over n plus 1 into AB. Similarly, if we know the value of D, we know the first term, we can find the value of H1, because H1 is the second term of the harmonic progression. So it will be equal to 1 over H1 is equal to 1 over A plus D, because 1 over H1 and 1 over A1 will be the terms of the corresponding AP, so we can use the formula for AP to find the next term. And solving it, we get A n plus B over n plus 1 into AB. Now if R is equal to 1 and n is equal to 1, substituting the value of R is equal to 1 and n is equal to 1 here, we get H1 is equal to 2AB over A plus B, and this gives the harmonic mean between the two numbers. So therefore, if we insert one harmonic mean between two numbers A and B, the harmonic mean will be equal to 2AB over A plus B. Now some important points related to harmonic mean. The harmonic mean of n positive numbers A1, A2, A3 and so on up to An is 1 over H is equal to 1 over n multiplied with 1 over A1 plus 1 over A2 plus 1 over A3 plus so on up to 1 over An. For example, if we want to find the harmonic mean between the numbers say 1, 2 and 3, the harmonic mean will be given by 1 over H is equal to 1 over 3, because 3 numbers are there, multiplied with 1 over 1 plus 1 over 2 plus 1 over 3. If A, G, H are the arithmetic, geometric and harmonic means between the three given numbers A, B, C, then the equation having ABC at its root will be given by this equation: x cube minus 3ax square plus 3g cube by h into x minus g cube is equal to 0. Now is the relation between the arithmetic mean, geometric mean. The relation between the arithmetic mean and the geometric mean is we can find now here A, we know that it's equal to A plus B by 2, G is equal to square root of AB. If we subtract the 2, we get A minus G is equal to A plus B by 2 minus the square root of AB. Taking 2 as a common denominator, we get A plus B minus 2AB by 2. And this A plus B minus 2 square root of AB, we can write it as square root of A minus the square root of B whole square. And 2 we can write it as square root of 2 whole square. Now since it's a squared term is always greater than 0. So we get A minus G is greater than 0 or A is greater than G. So this is the relation between the arithmetic mean and the geometric mean. The arithmetic mean of numbers is always greater than the geometric means of the same numbers. Now these are some important points related to arithmetic mean, geometric mean and the harmonic mean. If A is equal to B, then arithmetic mean, geometric mean and harmonic means are always equal. Second, if A is not equal to B, arithmetic mean is always greatest, then is the geometric mean, and the harmonic mean is always least. And geometric mean is squared. The square of geometric mean is always equal to arithmetic mean multiplied by harmonic mean. Now here one problem, let small n belonging to capital N, that is a set of natural numbers, and n is greater than 25, that is n is equal to a value greater than 25, that is it can be 26, 27 and so on. And let AGH denote the arithmetic mean, geometric mean and harmonic means respectively of 25 and n. Then the least value of n for which AGH belong to 25, 26 and so on up to n is 49, 81, 169 or 225. In this case the answer is D. Now let's check how to arrive at the answer. Now we have the two numbers 25 and the last number is n, so we can find the arithmetic mean 25 plus n divided by 2. The geometric mean will be equal to square root of 25 multiplied by n. Square root of 25 is 5, so it will be 5 square root of n, and the harmonic mean is equal to 50n divided by 25 plus n. Now it has been already given that AGH, it belongs to the set of natural numbers. AGH is belongs to the set of natural numbers starting from 25 up to n. So therefore the values that we get here for A, G and H should be natural numbers. So 25 plus n by 2 should be a natural number. 5 square root of n should be a natural number. 50n by 25 plus n should be a natural number. Now for this square root of n to be a natural number, n should be a perfect square. So 225 from the options given there, 225 should be the perfect square. So therefore for n is equal to 225, AGH will always be the natural numbers. So therefore the correct answer is 225. Now the next is the arithmetico-geometric progressions. These are the progressions which consist of the terms which the sum part is arithmetic progression, the sum part is geometric progression. So such type of terms are known, or such type of progressions are known as the arithmetico-geometric progressions. A sequence whose term is obtained by multiplying corresponding terms of AP and GP is known as arithmetic geometric progression or arithmetico-geometric progression or AGP. Now whenever we have the problem solving to solve the arithmetico-geometric progressions, we generally use these three steps to solve the problem. The first is multiply the common ratio of the geometric progression. In this AGP, first of all we'll segregate the AP and the GP. From the GP we'll find the common ratio and then we multiply that common ratio. The second step is shift the new obtained series in step 1 by 1 term. So the second series that we get, we shift it by one step, and the third is subtract the two series, that the first series and the second series that we obtained from the second step. Those two we'll subtract and then solve it. Now let's take one problem. Here we want to find the sum of 1 plus 2 into 2 plus 3 into 2 square plus 4 into 2 cube plus so on up to 100, 2 raised to the power 99. Now this one is an AGP because here 1 we can write it as 1 into 1. Further it can be written as 1 into 2 raised to the power 0. The second is 2 into 2 raised to the power 1. 3 into 2 raised to the power 2, 4 into 2 raised to the power 3. So the first term of the first part of every term is an arithmetic progression. 1, 2, 3, 4 and so on up to 100. The second part of every term is 2 raised to the power 0, 2 raised to the power 1, 2 raised to the power 2 is a GP, and therefore its common ratio is 2. So therefore the first we got S is equal to 1 plus 2 into 2 plus 3 into 2 square and so on up to 100 into 2 raised to the power 99. Now since the common ratio we got 2, we multiply 1 by 2. So we get 2S is equal to 1 into 2 plus 2 into 2 square plus 3 into 2 cube plus 4 into 2 4 plus so on up to 100 into 2 raised to the power 100, because it will be 2 multiplied by 2, 2 raised to the power 99 into 2 will be 2 raised to the power 100. Now we'll subtract 1 minus 2. So if we subtract this 1 and 2, this minus this, so we get 1, because we have shifted this 1 forward, will shift this 1 forward, so 1 minus 0 will come, because here if we shift it rightwards, 0 will be there, so it becomes 0 plus 1 by 2, so 1 minus 0 will come. Then 2 into 2 minus 1 into 2, then 3 2 square minus 2 2 square, 4 2 cube minus 3 2 cube. So like this we'll subtract these 2, so subtracting will get s is equal to 1 plus 2 into 2 plus 3 into 2 square and so on. So subtracting this we get s and 2s, 1 minus 1, 1 minus this will be 0 because we have shifted it rightward, so 1 minus 0 is 0, 1 minus 0 is 1, 2 into 2 and then 1 into 2, so it will be 2, then 3 into 2 square, 2 into 2 square, so 3 minus 2 is 1, so 2 square and so on up to we get minus, the last term will be left alone, so it will be minus 100 into 2 raised by 100. Now adding it here, we see that this is 1, then 2, then 2 square, 2 cube, so on up to 2 raised by 99. So we can take, we can use that geometric progression formula. So it will be 1 into 2 raised by 100 minus 1 over 2 minus 1. Because this term we can write it as 2 raised by 0. So it will be up to 99 and minus 100 into 2 raised by 100. Solving it, we get 2 raised by 100 minus 1, because this 2 minus 1 will be 1, minus 100 raised by 2 raised by 100. So minus s will be equal to minus 1 into 100. From here we get 1 and from here it is 100, so minus 100, 1 minus 100, 2 raised by 100 will be common, minus 1 will come from here. Now this will be minus 99 into 2 raised by 100 minus 1, and since it is equal to minus s, so therefore s will be equal to 99 into 2 raised by 100 plus 1. That will be the correct answer. Now is to, there are certain formulae that we should remember whenever we solve the arithmetico-geometric progressions. These are the summation of n square, summation of n cube. Summation of n, that is 1 plus 2 plus 3 plus so on up to n, is equal to n into n plus 1 by 2. Summation of n square is n into n plus 1 into 2n plus 1 by 6. Summation of n cube is equal to n into n plus 1 into 2n plus 1 divided by 6, and it is equal to n into n plus 1 divided by 2 whole square, and since n into n plus 1 divided by 2 is equal to summation n, so it will be equal to summation n whole square. So these three important formulas, summation n square and summation n cube. Now let's take one problem to find the sum of the series 3 into 1 square plus 5 into 2 square plus 7 into 3 square plus so on. Here the correct option is B. This is an AGP where 3, 5, 7 are in arithmetic progression, and this 1 square, 2 square, 3 square. So here also we have 1, 2, 3. This is also in arithmetic progression, and we have to find the square and then multiplication of the two terms. Now the given series, we can write it as nth term as nth term of 3, 5, 7 and so on multiplied by nth term of 1 square, 2 square, 3 square and so on. Now nth term of 3, 5, 7, this is an arithmetic progression, so it will be equal to 3 because 3 is the first term plus n minus 1 into 2 is the common difference, multiplied by, here also the first term is 1, so 1 plus n minus 1 into the common difference is 1, so whole raised to the power 2. Now solving this, we get 3 plus 2 n minus 2, And solving this one, we get 1 plus n minus 1 whole square, 1 and 1 cancel, n square. And solving this also, we get 2n plus 1. So after solving this, we get 2n cube plus 3n plus n square. So therefore, the nth term of this series is 2n cube plus n square. Now we want to find the sum, so sum will be equal to summation of the nth term. So this will be equal to summation of 2n cube plus n square, and this is equal to summation. This will be equal to 2 into summation of n cube plus summation of n square. 2 is a constant, so we'll take it out. It will be equal to 2. Summation of n cube is equal to n into n plus 1 by 2 whole square, plus summation of n square is equal to n into n plus 1 into 2n plus 1 divided by 6. And solving it all, we get n into n plus 1 into 3n square plus 5n plus 1 divided by 6.